relations in Z, then which of the following is an equivalence relation? M is related to N if and only if product of these is greater than equal to 0. M is related to N if and only if product of Mn is strictly greater than 0. M is related to N if and only if mod of M equal to mod of N, and M is related to N if and only if product of Mn is strictly not strictly less than and equal to 0. And we have to check that which one relation is showing equivalence relation. So we need to check each option one by one. So for first option, M is related to N if and only if product of Mn is strictly greater than 0. So if we choose two elements which are coming from set of integer, then product of them will be, because of if M is related to N, then product of them is strictly greater than 0. It means product of Nm will be again greater than 0. So this condition is satisfied by all elements which are self-related, means A is related to itself if and only if A square is always greater than equal to 0 if we choose either 0 or any non-zero number. So this relation is reflexive. Now need to check transitive in this relation. If M is related to N, if and only if product of Mn is greater than 0, it means Nm greater than equal to 0. This implies that N is related to M. So this relation is symmetric. Now need to check transitive. So option C, if M is related to N, if and only if product of Mn is greater than equal to 0 and Nt N is related to T if and only if product of Nt is greater than 0. Now we have to check that product of N and T means M and T are related or not. If they are related, it means their product must be greater than equal to 0. So for this transitive property, choose M equal to 1, N equal to 0 and T equal to minus 1. So product of Mn will be 0. So first relation is defined, as you can see with the help of red pen. This product is defined. When n equal to 0, then nt product of again this is 0. So this relation or condition is satisfied. Now we have to check m with t. Product of these one will be minus 1 and this is less than 0. So this condition is not satisfied, means m or t is not related. That means first relation is not equivalence relation. Now need to check option B, M is related to N if and only if Mn is strictly greater than 0. M is related to N if and only if product of Mn is strictly greater than 0. So if I take M equal to 0, then 0 is not related to 0 because of product is 0, which is not greater than is strictly 0. This condition is not satisfied. So this relation is not reflexive. So not a equivalence relation. You can check other condition also, symmetric and transitive relation in option B. So check option C. M is related to N if and only if and only if mod of M equal to mod of N. So every element have absolute value is equal to itself. So this relation I'm talking about option C. C is reflexive. Now need to check transitive. So if M is related to N, it means that absolute value of M is equal to N. So again N will be related to M. So this relation is symmetric. Now need to check transitive. So if M is related to N, this implies mod of these two equal. If N is related to another element T, this implies that mod of N is equal to mod of T. Now combine these two, mod of M equal to mod of T implies that, or you can write if and only if mod is equal, so M and T is related. So option C will be correct. Now check option D. If M is related to N, if and only if M is related to N, if and only if product of these two is less than equal to 0. So M is related to N, it means that product of these is strictly, so not strictly, less than equal to 0. So all elements will satisfy this condition. This relation will be symmetric and transitive also, because of product of, if Mn is less than equal to 0, then Nm product of, because of integer follow commutative property. So again this one, so this relation is symmetric. Now need to check transitive. So if M is related to N, if and only if product of Mn is strictly less, not strictly less than equal to 0. If N is related to T, if and only if M is related to T, if and only if Nt is strictly less than 0. So we need to check about relation of N and T. N and T will be related to each other if product of these two should be less than equal to 0. So consider M equal to 0, N equal to 1 and T equal to minus 1. So product of Mn equal to 0 means less than equal to condition satisfy. Nt, product of Nt is equal to minus 1. So again is condition less than equal to 0 satisfy. But whenever I need to check mt will be 0, and this condition is again less than equal to 0. So we need to take counter example. So make m equal to -1. Then product of mn is less than -1, less than equal to 0 condition satisfy. Nt is -1, less than condition is satisfy. Then mt, product of mt will be positive because of value of m is -1 and value of t is again -1. So their product will be greater than equal to 0. So transitive field. So option D is not equivalence relation. So only correct option is C,